Good morning, middle one. Today we are going to talk about lesson 2 of unit 1, which is talking about the chemical compounds. As you know before from the last session that all the metals tend to lose their outermost electrons and the nonmetal tend to gain electrons. These number of electrons are called valency. So what's meant by valency? It is the number of electrons that the atom gained or lose or even shared during the chemical reaction. So by this way, you have to know that the valency of noble gases is zero. Why? Because their outermost energy level is completely filled with electron. I mean that they don't lose or gain or share any electrons. So, to know what's mean by valency more and more, let's take examples. First, you have to know that we have sodium atom, which is metal. The sodium will lose an electron from the last level to be stable. So, its valency will be 1. Why 1? Because it loses 1 electron. Another example for oxygen. The oxygen atom gained 2 electrons, so the valency will be equal to. So you have a table of some elements and their valence electrons. You have to remember this table very well because it's very important. In this table, we have the metals and non-metals with their symbols and their valences. So first, let's talk about the metal and this and their valency. First, the lithium. The valency of lithium is 1. You have to know, instead of saying the valency of lithium is 1, you can write the lithium is monovalent. Monovalence. What mean by monovalent? Mono means 1. So the lithium has valency equal 1 or monovalent. Next, potassium. The valency of potassium is 1 or monovalent. The valency of sodium is 1 or monovalent. The valency of calcium is 2 or divalent. Di means 2. The valency of magnesium is 2 or divalent. The valency of aluminium is 3 or trivalent. Tri means 3. The valency of zinc is 2 or divalent. The valency of iron, take care because iron is an example of metals which has more than one valency. The iron has two valencies, 2 and 3. Or you can say the iron is divalent and trivalent, has two cases. The valency of lead is 2 or divalent. The valency of copper, take care, we have another example of the metal that has more than one valencies, which is a copper. The copper may be monovalent or divalent. The mercury, the valency of mercury is 2, the valency of silver is 1, the valency of gold is 3. To study this part very easy, collect the metals that have the same valencies together. Example, collect the metals which have valency equal 1 together and the metals that have valency equal 2 together and so on. Now let's talk about the nonmetals. The valency of hydrogen is 1. The valency of chlorine 1, fluorine 1, bromine 1, iodine 1. Take care, collect the nonmetals that have the same valencies together, like hydrogen, chlorine, fluorine, bromine, and iodine. Next, collect the nonmetals that have valencies which equal 2 together, and we have only one, which is oxygen. Oxygen is the only divalent nonmetal here. And we have carbon, which its valency equal 4, or you can say tetravalent. Tetra mean 4. And we have some examples of nonmetals that have more than one valency, like nitrogen and phosphorus. They have valency equal 3 or 5. I mean trivalent or pentavalent. Penta mean 5. And finally we have nonmetal which has more than one valency, three valences, which is a sulfur. Sulfur has valency equal to 4 or 6, I mean divalent or tetravalent or hexavalent. Hexa means 6. From the last table, we have some elements that have more than one valency like iron. Iron has two different valencies. First, we have iron called ferrous, and this type loses 2 electrons, so its valency equal 2. And we have another type of iron which loses 3 electrons, so its valency equal 3. And if we talk about the copper, we have two types of copper, copper 1 and copper 2, and from their names, their valencies, which I mean the copper 1 is monovalent and the copper 2 is divalent. If we talk about the sulfur, sulfur is non-metal that have three valences, 2, 4, 6, or you can say divalent, tetravalent and hexavalent. Finally, we have the nitrogen and phosphorus. They like each others. They have valency equal 3 or 5, or you can say trivalent or pentavalent. Now let's talk about something called atomic group. What's meant by atomic groups? They are set or group of atoms joined together and behave like one atom only, have its special valency and can't be existed individually. And we have here a table of the atomic groups and their valencies. Take care, this table is very important. You must keep it in your mind very well. First, we have atomic group called hydroxide, and its symbol is OH, negative charge, and its valency equals the number of a charge, so the valency equal 1. Next we have nitrate. Its symbol is NO3 and carry 1 negative charge, so its valency equal 1. We have bicarbonate. Bicarbonate, its symbol HCO3, which carry only 1 negative charge, so its valency equal 1. And next we have nitrite, and its symbol is NO2. It's carry 1 negative charge, so its valency equal 1. And we have something called ammonium, and its symbol is NH4, which carry 1 positive charge, and its valency equal 1. Take care, the ammonium is the only monovalent atomic group which carry different atomic charge from the other. Next we have sulfate, SO4, which carry negative 2 charges, so its valency equal 2. And we have carbonate, which its symbol CO3, which carry also 2 negative charge, so its valency equal 2. Finally we have phosphate, which its symbol BO4 and carry negative 3 charges, so its valency equal 3. Now you have to know that we can write any molecule of any compound by formula, and this formula called chemical formula. So now let's learn how to make the chemical formula of compounds. First we have rules. The first one is to write the name of compound in words. The second one is to write the symbol of each element or the atomic group down the name. Third one is to write the valency of each atom down to each symbol. And the last one is to replace the written numbers. We have here an example. Write down the chemical formula of sodium carbonate. First, we will write the names, sodium and carbonate. And we will write the symbol of each one below it, sodium Na, carbonate CO3. Next we will write the symbol of each one below it. The valency of sodium is 1. The valency of carbonate is 2. Now the last step is to exchange the numbers. I mean that the Na will take the 2 and CO3 will take the 1. So the chemical formula will be Na2CO3. Okay, and we have here some compounds and their chemical formula. Take care, we must start by the left with metal or hydrogen or positive atomic group, and we will end by non-metal or negative atomic group. The word oxide means that this reaction is done with oxygen. Now let's talk about types of compounds. Compounds are divided into acids, bases, salts, and oxides. Now let's talk about acids. Acids are substances that when they dissolve in water, they produce positive hydrogen ion or H positive. What are the properties of acids? All acids have sour taste and they can change the color of litmus paper to be red. Why? Due to the presence of hydrogen ion. We have here some examples on acids. The first one, hydrochloric acid, HCl, sulfuric acid, H2SO4, nitric acid, HNO3. Take care, all the acids must begin with H, like HCl, H2SO4, HNO3. Now let's talk about the bases. All bases are substances that when they dissolve in water, they produce negative hydroxide ion, which is OH negative. The properties of bases, they have bitter taste and feeling slippery. And they can change the color of litmus paper to be blue. Why? Due to the presence of hydroxide ion or OH negative. We have here some examples on bases. First one, sodium hydroxide or NaOH, potassium hydroxide KOH, calcium hydroxide CaOH by 2. Take care, all the hydroxides end by OH. So now you have to take care. All acids begin with H. All hydroxides end with OH. Now let's talk about oxides. What's meant by oxides? Oxides are resulting by combination or reaction between oxygen and element. Whatever this element is metal or non-metal. We have here some example. First, sodium oxide or Na2O, aluminium oxide Al2O3, carbon dioxide CO2, sulfur trioxide SO3. Now let's talk about salts. Salts are produced as a result of chemical combination or reaction of the positive metal ion or positive atomic group with negative non-metal ion except oxygen ion or a negative atomic group. And here we have some example on salt. We have two types of salts. Salt dissolved in water and salt undissolved in water. First we will talk about the salts that's dissolved in water. The first one, sodium chloride, which is NaCl, potassium sulfate K2SO4, calcium nitrate CaNO3 by 2, sodium sulfide Na2S. Now let's talk about the salts undissolved in water like silver chloride AgCl, lead iodide BpI2, lead sulfate PbSO4. You have to know all of carbonate salts don't dissolve in water. All the carbonate salt don't dissolve in water except sodium carbonate and potassium carbonate and ammonium carbonate.